Have you ever bent a paperclip back and forth until it snaps? That's fatigue. Now imagine that happening to the metal parts of an airplane. This is aircraft fatigue, a hidden danger that can have catastrophic consequences. It's the weakening of an aircraft's structure over time due to repeated stress and strain. Every takeoff, landing, and maneuver puts stress on an aircraft's frame, engines, and wings. These repeated stresses, even tiny ones, can cause microscopic cracks to form. Over time, these cracks grow, just like the paperclip that eventually breaks. This is a serious issue because it compromises the structural integrity of the aircraft. It can lead to parts failing mid-flight, potentially leading to accidents. Understanding aircraft fatigue is crucial for ensuring the safety of everyone on board. Flying takes a tremendous toll on an airplane, far more than most people realize. Every journey through the sky exposes the aircraft to a relentless series of physical challenges. Imagine the force of taking off and landing thousands of times throughout an airplane's life. Each takeoff and landing is a jolt, a shockwave that travels through the entire structure, testing its strength again and again. The constant changes in air pressure at high altitudes also put stress on the aircraft's structure. As the plane climbs and descends, the fuselage expands and contracts, flexing with every cycle. Think of it like squeezing a plastic bottle over and over again. Eventually, the material weakens and cracks, no matter how strong it seemed at first. This is similar to what happens to an airplane over time. The metal skin and joints slowly accumulate tiny cracks and signs of fatigue. The constant cycle of pressurization and depressurization during flights puts stress on the fuselage, much like the squeezed bottle. Over time, these cycles can cause microscopic damage that grows with each flight. Then there's the stress from turbulence, wind gusts, and even the weight of passengers and cargo. All these factors combine to create a challenging environment for the aircraft. These forces might seem insignificant individually, but over countless flight hours, they add up, contributing to the fatigue process. The effects are gradual, but they are always present. It's like constantly bending a wire. Eventually, it will break. The repeated stress, even if small, leads to failure if not carefully monitored. This constant wear and tear are unavoidable aspects of flight, but understanding their impact is crucial for managing aircraft fatigue. Through regular inspections and advanced engineering, we can keep planes flying safely, despite the unrelenting strain they endure. Aircraft fatigue doesn't discriminate. It can affect any part of the plane subjected to repeated stress. However, some areas are more vulnerable than others. Take the wings, for example. These crucial structures endure immense stress during every flight. The constant flexing and bending, especially during turbulence, can cause cracks to develop near bolt holes, joints, and other high-stress points. Engines are another critical area. The constant vibrations, extreme temperatures, and high-speed rotations they experience make them susceptible to fatigue. Cracks in engine components like turbine blades or discs can have disastrous consequences. Even seemingly minor components like landing gear can suffer from fatigue. Imagine the impact of landing a heavy aircraft hundreds or thousands of times. The constant stress on the landing gear can lead to cracks and weaken its structure. While not exactly fatigue, corrosion is a close ally that exacerbates the problem. Corrosion is like rust, eating away at the metal and weakening it from the inside out. Think of it like this. If fatigue creates tiny cracks in the metal, corrosion widens and deepens those cracks, accelerating the fatigue process. This is especially problematic in areas exposed to moisture and salt, like the underside of the fuselage or near the engines. Corrosion can also occur inside fuel tanks, especially if water contaminates the fuel. This can lead to pitting and weakening of the tank walls, potentially causing leaks or even catastrophic failures. Regular inspections and maintenance are crucial for detecting and addressing corrosion. By controlling corrosion, we can significantly slow down the fatigue process and ensure the aircraft's longevity. Detecting fatigue is like finding a needle in a haystack. The process is both challenging and crucial, as the safety of every flight depends on catching even the smallest signs of wear before they become a problem. The cracks are often microscopic and hidden within the aircraft's structure, making them nearly impossible to spot with the naked eye. These tiny flaws can develop over time due to repeated stress and pressure during flights, but thankfully, experts have developed sophisticated methods to uncover them. Teams of engineers and technicians work together, combining their expertise to ensure nothing is overlooked. One such method is non-destructive testing, or NDT, which is a cornerstone of modern aircraft maintenance. This involves using advanced techniques like X-rays, ultrasound, and eddy current to inspect the aircraft without causing any damage. Each method is chosen based on the part of the aircraft and the type of material being examined. These techniques allow inspectors to see inside the metal, revealing any hidden cracks or defects that could compromise safety. Digital scans and monitors provide real-time feedback, making the process more accurate. Another important method is visual inspection, which remains a fundamental part of the process, despite all the technology available. Trained technicians meticulously examine the aircraft's surface, looking for any telltale signs of fatigue, such as paint flaking, small dents, or suspicious marks. Their experience helps them spot subtle changes that machines might miss. These visual cues often provide early warnings of underlying structural issues, allowing for timely repairs before problems escalate. These inspections are not a one-time affair. They are part of a continuous process that keeps every aircraft airworthy and safe for passengers and crew. They are conducted at regular intervals throughout the aircraft's life, ensuring that any potential fatigue issues are identified and addressed promptly. This ongoing vigilance is what keeps aviation one of the safest modes of travel in the world. Ensuring aircraft safety is a paramount concern, and that's where the Federal Aviation Administration, or FAA, steps in. The FAA is the primary regulatory body in the United States, responsible for overseeing all aspects of civil aviation, from pilot licensing to air traffic control, and most importantly, the safety and maintenance of aircraft. The FAA sets strict regulations and guidelines that airlines and manufacturers must follow to prevent fatigue-related accidents. These rules are designed to ensure that every aircraft in the sky meets rigorous safety standards, and that any potential risks are identified and addressed before they can become serious problems. One crucial concept in aviation safety is the flight cycle, which plays a major role in determining how often an aircraft needs to be inspected and maintained. A flight cycle typically consists of one takeoff and one landing. Each time an aircraft completes this cycle, it experiences significant stress on its structure and components. The FAA mandates that aircraft undergo rigorous inspections and maintenance based on the number of flight cycles they've completed. This ensures that any wear and tear caused by repeated pressurization and depressurization is caught early. These inspections become more frequent as the aircraft ages or accumulates more flight cycles. Over time, the repeated stress can lead to metal fatigue and other issues that, if left unchecked, could compromise safety. This is because the risk of fatigue increases with the number of stress cycles the aircraft has experienced. Detecting early signs of fatigue is crucial to preventing structural failures. Think of it like a car needing more frequent servicing as it gets older and the mileage increases. Just as you wouldn't ignore regular oil changes or brake checks on a high-mileage car, aircraft maintenance becomes even more important as they age. Similarly, aircraft require more attention and maintenance as they age and accumulate flight cycles to ensure their continued airworthiness. This careful monitoring and adherence to FAA guidelines is what keeps air travel one of the safest modes of transportation in the world. The fight against aircraft fatigue is an ongoing one. Thankfully, with regular maintenance, technological advancements, and stringent safety regulations, flying is safer than ever before. Airlines have robust maintenance programs that include regular inspections, repairs, and replacement of parts nearing the end of their lifespan. This proactive approach helps to identify and address fatigue issues before they become critical. Moreover, advancements in material science have led to the development of stronger and more fatigue-resistant alloys. These new materials are being incorporated into newer aircraft designs, further enhancing their structural integrity. Researchers are also exploring innovative technologies like sensor networks that can monitor an aircraft's structural health in real time. These sensors can detect minute changes in stress and strain, providing early warnings of potential fatigue problems. Aircraft fatigue is a serious concern, but thanks to rigorous safety protocols, continuous innovation, and the dedication of countless professionals, flying remains one of the safest modes of transportation. By understanding the causes of fatigue, diligently inspecting aircraft, and implementing robust maintenance programs, we can continue to mitigate risks and ensure the safety of passengers and crew members worldwide. As technology advances and our understanding of fatigue grows, we can look forward to even safer skies in the future.